Okay, I will talk about your homework one. For the homework one, we have 5 questions, and today we will explain 3 questions, and you need to hand in your homework after 2 weeks, which is I will explain later 10:20. And if you have any question about homework, you can send email to this email address, and ask for any question about homework or lecture. And you can also go to our lab, which is in our faculty 9th floor, and during the office hour. So I show you 2 of them in here. So for the homework one, we have some reminder, which is copying homework is strictly prohibited. If the TA found you copy your homework, your penalty is your score will be 0 for both person. And because today we will explain 3 questions, and this 3 questions you need to hand in on October 20 and morning, in the morning, 9 a.m. And then please hand in your homework before deadline, because if you are late, up to 7 days late, you will lose 50% of your score. And after 7 days, the score will be marked as 0. And you must attend the demonstration to show that your code will work. So the demonstration schedule will be announced on Moodle. So you need to catch up the news of our Moodle post. And every question you should make a GUI, a user interface, or you will get some penalties. And your homework should upload to our FTP, which is our IP here. And you should put your homework in this folder, homework 1, part 1, because you will have part 2, which is question 4 and question 5, and we will explain it later. But today we will just give you 3 questions. And you can see the user ID and password here. And for your homework, you should follow this format, which is homework 1 and student ID and your name and your version, because you may modify your answer. So you should give your version here. We will use the newest version as your answer. Okay. For the environment, we recommend you to use Python to do your homework, and we will use Python 3.7 and OpenCV, this version 3.4.2. And you may use Matplot library to display some image. This is a useful package. And for the UI framework, you should use PyQt5 to do it. And if you want to do it in C++, wait, and you can see MFC guide in FTP. MFC is a UI framework in C++. Yes. Okay. So for the question 1 to question 3, you should do it in one UI. And for the loading image, you please don't fix your image path, because we will have another data set for demonstration. So you may change your directory of the image. So you can make a free button here for loading free image for this free question. Okay. And for the first question is the camera calibration about. And the second question is about augmented reality, AR. And the third question is the stereo disparity map, which is you have just learned. And I will talk about camera calibration first. For camera calibration, you should first load a folder, and if you press this button, you should load all of the image in that folder. Because for camera calibration, you may need multiple image to find some intrinsic matrix or extrinsic matrix. So this is an important step, so you should do it. Okay, for 1.1, we will do a corner detection on this chessboard. Like here. We will have like a folder of image, and you need to do the chessboard corner detection by calling the OpenCV function. Okay, and you can there's some hints you can find in the textbook, OpenCV textbook chapter 11, page 398 to 399. And you may use the OpenCV function find chessboard corner here to do the corner detection. This is the first step. And after the finding the corner, we can find the intrusion matrix of the camera. So we'll give you 15 image, BMP image, and you need to find the intrusion matrix and print it out like this. And you may also find the reference on OpenCV textbook chapter 11, this page. So for this function, you may do it in this button, 1.2 find intrinsic. After finding intrinsic matrix, we will ask you to find extrinsic matrix. Okay. Extrinsic matrix, you can see the chessboard from the chessboard image, 15 chessboard image, and you can see the rotation here and translation here. So you print it. If you find it, you print it out like this. And this you can just also see the reference on the chapter 11 and this page. Because for the extrinsic matrix, you will have 15 image, and they have 15 different extrinsic matrix. So you need to choose it here, from 1 to 15. And if you choose one and you press this button, find extrinsic, and you will print it extrinsic matrix of image 1. Okay. And after finding extrinsic matrix, you need to find distortion matrix. For the distortion matrix, you can also just have reference about this in chapter 11. And because this distortion matrix is only 1, and you can find 15 image, you have 15 image to find one distortion matrix. So you just press this button and print it out. Okay, and this quite simple. This is a simple question about camera calibration, and this is question 1. Okay. If you have any question, you can also come to our office hour, come to our lab during the office hour, or send email to us. Okay, so we will start to talk about question 2. Oh, we still have one question on question 1. Is after you find the distortion matrix, you should show the undistorted result. So this is, you need to use this part 1.4. If you find the distortion matrix, you can use it to help you to recover an undistorted image. Okay. Yes. And you may use the OpenCV undistort, this initial undistort rectify method. You can also see reference on chapter 11. Yes. Okay, so this is the end of question 1.
And next, I will talk about the question 2. First, you also need to load the fold image folder by this button. And in the question 2, we try to implement the argument reality based on camera calibration. And after the camera calibration of camera, we can think of the chessboard as a match. You know the position of every corner on the chessboard. So we can use this corner position to implement the AR. And first, you need to calibration, and you will get some required parameter. And second, you need to input the words you want to show on the example. You want to show on the chessboard. And in this example case is camera. 3, you need to divide the shape of words by using the provided library, and I will talk about the next page. 4, and finally is you need to show the words on the chessboard, and the result image will look like this. The words will show on the chessboard and vertical show on the chessboard. Next, I will talk about how to show the words on chessboard. We copy the chessboard to 6 regions, and each region there is 9 points on each region. So we can show each character be placed in order like this: 1, 2, 3, 4, 5, 6. And how to use the library we provide. You can follow this step. First, you need to use OpenCV to load the text file, and you can find the character by like this. You can use getNotice function to get the characters matrix. And we take the K for example. K consists of 3 lines. And so this array consists 3 pairs of 3D coordinates. And 220 and 200 represent this vertical line, a red line, and 020, 210 represent this blue line, and 210, 000 represent this green line. And this is how to use our library. And this is about the question 2. Next, my partner will talk about the question 3.
Okay, the next question is stereo disparity map, and this has 2 sub questions, and you have to load 2 images separately from the UI, like these 2 buttons. Okay, the first is you need to find a disparity map from 2 images. I will give you a pair of images, and you need to find a disparity map based on the left and right disparity images. And there are some guides. First, window size must be odd and within a range from 5 between to 55. And search range and direction. Disparity range, it must be positive and divisible by 16. And map disparity range to graph value range 0 to 255 for the purpose of visualization. And if the left image is a reference image, the one used to calculate depth in for each pixel of image, then the search direction at right images will go from the right to left direction. And I will give you the camera information here, and you can get hint from the textbook chapter 12. And the function, I give you a function here. So you want load 2 image like image left and image right, and you will get the result is disparity map here. The second question is you will check disparity value. You will click at left images and draw the corresponding point at the right image. And let's watch the result video here. You click on the left images and the right images will show the corresponding point. Point is green. Users should allow to repeat the first small requirement. And there is a note. Okay. Okay. Okay, if I click at this small clock dial and the right image will show the green point, and I click at the chair, it shows the corresponding point. And there is a note. Click at the correct position in disparate match result from previously subtraction and ignore the position with zero disparity. Okay, so this is the disparity match. And if you have any question, you can come to our lab or send emails to class TA.
Yes, you can also discuss your homework remote. Okay. Okay. If you want to discuss your homework with your classmate, you can also discuss it on Moodle. We have a forum for you to discuss about homework. And you can also find your teammate of final project in there. So you can just use the forum in Moodle. Thank you. Thank you.
We don't change anything. 给你们那个哦，如果不够您先去买，
好，没关系。
不够我再跟我要钱。
好好好，
就午餐
谢谢。
150少。OK， 好，一定不够，还不够，你再跟我要。好，谢谢。Hey, wait. There are questions. Do we have to do all 3 questions as the homework? Yes. You should do all the homework. You can see that the one, yeah. Yeah, you should do all the questions. Can we find the slide on FTP, right? Yeah, we'll put on FTP so you can download it. Okay. Thank you. Yes, the answer is yes. Thank you. We continue. But I also encourage suppose we have 5 questions for each homework. Okay. And I encourage 5 of you, each of you can be one group. And then you can discuss the question. Or you can, like when I was in the United States, how can we do the homework with the American students? I learned from them. What I do is like five students together for 5 questions. And then before we discuss before the meeting, I mean the group meeting, each one will assign one question, and then each one will study their question, and they will think about how to do that, and then we group together during the meeting. Each one will explain how he solved the questions, to share with others, but don't copy that one. And so during the meeting we can understand almost all the procedures or even all the answers, and you go back and just start to do the homework. But during the time you do the homework, you still can keep discussion with each other. And then after you finish your homework, you can try to try to talk to the other partners, say, okay, what's your answer? You can double check your answer. But remember, don't copy. But if you still have a question, you can discuss with the partner or go to the TA to ask them questions. 所以我的课文是鼓励大家讨论的但不要抄这样子你这样才会节省时间就五个人每个人分，因为we have a final project still, so final project is for each group, but for homework everyone should do by its own. So everyone should turn in the homework. But for the final project, each group has 5 person. You just need to turn in one project. Okay, the project will include the source code, include the PPT. 就期末报告就是每组只要 turn in 一个就好了这样子。那 homework 是每个人都要去做好 Now we continue explain this one. So how can we do this one? How can we calculate it? What's the equation come from? So based on this one, this is a triangular between. So we have 3 triangle. One is the XU1, U2. The other X C1 and C2 is this one. Small one and the big one. Okay, so you have two kind of triangle, similarity triangle. So for the big one, your Z, the height is Z. Your base is a baseline, B. B is the distance between 2 cameras. You put the 2 cameras, you can measure the center to center. So this can measure. So distance between 2 cameras. So Z compared with the base equal to this one. So this is your length. So equal to the height is Z minus F. So this Z minus F. Compare with the distance here. So that's this way. So Z minus F is a height compared with small triangle. Height compared with height is base compared with base. So right now the problem is what's the distance between this one? So the distance actually is a different base B. And here, suppose this is a camera, the center, the middle, the principal point. So you have X distance here. Suppose this is a principal point. So you have the other distance here. This coordinate. But in this example, we have a direction. It's a vector direction. So in right hand side, this is a positive. Left hand side is negative. So in this image, the U1 is positive. In this direction, the U2 is negative. So if you ignore this one, you just suppose this actually there's a distance between. So when I say U1 minus U2, because U1 is positive, U2 is negative direction. So U1 minus U2 actually equal to the U1 distance plus U2 distance. But don't worry about this one. I will talk about this one later. So that's meaning you have B here, and you have distance. This U1 plus U2. If you forget the distance, so this U1 plus U2, and so B minus U1 and minus U2 will be equal to this one. So will be here. So this will be your equation. And U1 minus U2 is the disparity. They call disparity here. So we define this one with D. the disparity D will equal to, after you reorganize this one, will become this one. So you will find the Z minus F actually will be not so sensitive, so will become this one. And this is a disparity. But our purpose is try to find the Z, the test Z. So this you will actually reorganize again, will become this one. So that's meaning your Z, the test of Z, the Z compared with your baseline equal to, if baseline come to here, so if your Z test compared with baseline equal to your focal length compared with your D disparity， 就是说这式子也不用背了，这式子不用背，这式子我用简单的，因为推导完以后，我们简单的讲的话，就是说你的 Z 的深度嘛，大上 Z 的深度比上 B 就 baseline 上大概等于，因为是深度嘛哈，所以大概等于 F 就是 F 就是这 B 拿过来哈 ，Z 比 B 大概等于跟这个 F 了 ，F 比上你的 disparity， 就是 F 是深度嘛，那你这是影像坐标了哦。This will be coordinate in the image, and B and Z is coordinated in the world。就经过我们这个推导以后，你如果有推导以后，你会发现怎么去解释这个推导后的结果，比较容易记。因为这已经推导过了，那推导过的结果，我们都比较好记的话，就是说你会发现 Z 比 B 就是你的3D 就是那个世界坐标、物体坐标3D 嘛，就是 Z 比你的 baseline， 那在比较上等于你的影像坐标，你的影像坐标跟你的 camera 坐标了，这样就实际上是影像 camera 跟影像坐标是跟你的什么有关？跟你的焦距啊，你的 disparity 有关。这样就比较容易记了。一个是3D 坐标，一个是影像坐标。那 here be careful is about the unit， 小心一下，这个单位很重要。你算的时候单位很重要。3D 重建 ，usually your Z is like a centimeter， your baseline is centimeter， 但是 your 3D coordinate is centimeter。Your image plane F sometimes is a millimeter, sometimes is a pixel. Your depth, your disparity is pixel. A pixel you can transfer back to the mu n. So F and D is small, especially D is pixel. 每个 pixel 大概只占几个 mu n 而已哦。所以这个要小心一下，单位转换要小心一下。那所以。So based on this one, we will find that D is the most important one. And D is equal to, if we have a direction, D 假设有方向的，不，我们以方向来讲不是假设 ，D 有方向的是 U1 减掉 U2。那什么叫 U1 减掉 U2？ 基本上来讲就这个点过来就是它两点 corresponding point 的距离啦。D is disparity, that's meaning the distance between two corresponding points. That's D. So D is the same. So this is the corresponding point. Both points is corresponding point. So the distance between two corresponding points, that's your disparity. 那你把它到这里来想，就比较容易想啊。这一点绿色把它拿过来，那就是这两边的 corresponding point。那另外一个要注意一点哈，要注意一点是 ，this is your left side camera, this is your right side camera. So for each line, how do you find corresponding point? How do you find corresponding point? That's problems. So that's like a template matrix. We should find corresponding point based on, because one pixel cannot find corresponding point. One pixel only gray value or RGB value. But usually we do the stereo use gray value, not RGB, because RGB you spend 3 times more. So gray for the display for the stereo, we always use the gray value because we want to calculate in real time. If you use RGB, you spend too much time. Back to here. So the question is that you try to find this corresponding point between two different cameras, two different images, corresponding point. Okay. So, but what I try to say is that if you do this one, you'll find this. We always say left side is a reference image, 就是以我为主. So you will find your corresponding point. In right hand side, your corresponding point will be in your left side. If this is reference, you will find, because left side is meaning you use your left eye to see the object. Right side image is your right eye to see the object. So the same image, the same view, you'll find, if this is left, you'll find corresponding point on the right hand side. You'll find you only need to search one direction. The same, this one here, you try to find corresponding point, you only need to search one direction. That's meaning any corresponding point from right hand side to left hand side. If I move this point to here, you'll find, because you know this one, for each page, you'll find your corresponding point is at your left hand side. So you only need to search one direction. You don't need to search entire image. Okay, so be careful about this one, because what I said, stereo corresponding, finding corresponding point is most important thing. But how can we find a corresponding point in real time? That's very important. So we continue. So this is our equation. So right now our question is how can we find corresponding point? So this is the equation. So suppose you have a left image and right image, right? And you will try to find corresponding point. After you find corresponding point, there will be this will be a disparity, your distance. So one point, remember, one point cannot find corresponding point because the information is not enough. So we need to a page. So here we need to crop a page, a small page, and try to find corresponding point based on the page. But because we want to run it in real time, so page size cannot be too big. So the best page size is 3 by 3. So your page size will be 3 by 3. Sometimes people use 5 by 5. 5 by 5 is slow. So 3 by 3 is enough. Okay. 所以你要找 corresponding point 一定要一个 page 嘛，那 page 一点不行啊，一点找不到，所以这里就是这个。So suppose you have 3 points. Sorry, 3 by 3, so 9 points for the page match. So it's the same. This one, the symmetry measure is the same as deep learning convolution. Deep learning convolution, the same. They have a filter. The 3 by 3 filter, they do the convolution from the top left to the bottom right. So they search it, do the convolution for the entire images. However, here, the same. If you have 3 by 3, but this is not filter. This is a page, a template. And how do you find a corresponding point? Wait, you can do 3D scan line, but it's too slow. 你要用跟做 convolution， 你就用3×3这样去搜寻 scan 来搜寻的话，那你每点都要这样搜寻，那你没办法做 real time。那怎么办？所以我们找 corresponding point， 没办法整张影像去找，或找一个社区region不行。那我在这里再提一下 page 30。Try to find corresponding points. Sometimes, if you use 1 pixel here, First of all, you try to find corresponding point in page 30. You need to just along one direction. That's what I say. Just along one direction. You don't need to search the other direction because your left image in the right side image will be only in one direction. The second is it's a 2D search. The search region is 2D. Can we reduce to 1D search? Yes. So we will introduce one called epipolar. Epipolar is try to let you do the search from 2D search to the 1D search. That's called epipolar line. We can find this epipolar line. The third is what's the window size? So it's search region. So search region can be from 2D reduced to 1D. What's the window size? 1 pixel? No, 1 pixel is not good because we don't have enough information. If I use edge, pixel is can I use edge? Edge is meaning like the softball edge detection. You can reduce a lot of noise. Can we use edge? Yes, we can do. So some people, based on temporary matching, but they use the edge information. Okay. The third one is textual information. So when you try to do the matching, simulated measure, you can use the edge information. You also can use either use a pitch is textual information. The texture 纹路嘛 textual information。OK， 那这是 pitch， 这是 pixel 不一样哦。好，那再来就是 what kind of method you want to use, like a cost function. You want to use the sum of square difference, sum of absolute difference, or normalized cross correlation. 你要哪个方式来做比较好？但注意 ，stereo 的目的是快速要找到结果啊。好，所以我们通常用简单的方式来做。我们需要用简单的方式，所以我说 stereo equation 不难，难在你要做 real time， 那你要用简单的方式。But easy way will cause a lot of noise or mistake。好，那我们再继续。好，那我们就开始。How can we reduce the 2D search to 1D search? That's important. 2D search will take time. So how can we reduce only one direction? That's meaning when you try to find corresponding point, right? You crop this page and to hit around here, and you do the search, 2D search. That's not good. Can we find a line? Let's scan line. So this point, I can just try to initial point will be here and search along one direction. 就是说，我们要减少计算时间，那我不要做太大 search region， 那我可不可以用小的 search region？ 可以。那第二是我能把2D 的 search 变成1D 的 search， 那不是减少更多时间吗？所以这个我们就引入叫 epipolar 的东西，这个概念就是说，我把这个点，假设一个3×3的 page， 我拿过来，我可以找到这条蓝色的线，绿色线。这条绿色线就是我相对的点一定出现在这绿色线上。My corresponding line will appear the same scan called scan line. So from left side camera, I can find corresponding line in the right side camera. It's called epipolar. Corresponding line. I find corresponding line first, and then find corresponding point. And this is called epipolar. So I'll start talking about epipolar. We call epipolar geometry. So any point P, 3D P, and even camera coordinate. 1 and left, camera coordinate right. So any 3D they project on the 2D image left side called PL, small PL. In the right camera, right image called small PR. So any 3D points we project on camera 1, camera 2, or camera left, camera right, you projection 2 points. Our purpose is try to find the corresponding point P left and the P right. But so far we don't know which point is P right. So given any P left, can you find the P right? Okay, so we define epipolar. So epipolar is this one, the E left and E right. This is called epipoles. What's epipoles? Epipoles is meaning this is camera's left coordinate. This is the center of camera left. The same in the camera right. I can see this camera left. If I project to this image plane, and this point we call epipole. Epipole on right hand side image. 说你两个摄影机两只摄影机，我们摄影机先不要讲平行摄影机，我们讲说，假如两个摄影机有个角度，那这样我左边的影像还是可以看到，就我右边的影像右边影像 I can take the photo of this camera. So I can find the camera center at here. So this point called epipole of left-hand side camera to right-hand side camera. The same in the left-hand side camera, I can find the other epipole. So this one epipole is corresponding to the right-hand side camera. So this 2 points is called epipole. So the one is because we have only one camera in the left, one camera in the right. So the epipole only has one here. The epipole has only the other one here for each image. 每一张影像只有一个对应的摄影机的 epipole 投影到这里。那这里主要是跟你讲什么？讲说 this one P left, and you try to draw the line here. Cross the line connect to the epipole, and this corresponding the corresponding line here, based on the E left, your P right will appear on this epipolar line. I say again, any point on this image, so any 3D point project on the 2D image plane, you connect any point in image to the epipole. This line we call epipolar line. This epipolar line actually is this one. So any epipolar line on your left-hand side image, you can find the corresponding epipolar line on right-hand side image, and the corresponding point will appear at the epipolar line. 就是说，这个你任何的点，只要找到左边的任何一条 epipolar line 对应的右边的 epipolar line， 那这一点一定会出现，这两点一定会出现在这个 epipolar line 上面。你只要在这条上面去找对应点就好了。So 2D 的 search will become 1D search. So the purpose actually try to find the epipolar line. We can find that one. OpenCV provide you this kind of information. So the same, if you given any point in the right-hand side, and you have an epipolar line is any point pass through the epipole. And this point, this line, we can find corresponding epipolar line. And based on the epipolar line, we can find this one. You can find the corresponding point along the epipolar line. 它有这个特色。那这三点叫 epipolar plane， 就这一点跟这一点跟这一点，任何一点，so any point corresponding to C left and C right, they call epipolar plane。这样子。好，我们继续。这可能要想一下。So we define epipolar plane, epipolar line, epipole. Here important epipolar. Any point has its own epipolar plane. Any epipolar plane will intercept to one epipolar line. This is the other epipolar line. Okay. 那我们来看一下这里。这里。 So any point, suppose we have a point in 3D, the epipolar line, epipolar plane, this epipolar plane will intercept to the image. So this one will appear one epipolar line here, and the other epipolar line is dashed line. If the other point B in 3D the same, it's on epipolar line in the left hand side camera and the corresponding epipolar line in the right hand side camera. 任何一点在 3D 它都会可以跟两只摄影机构成 epipolar plane。那这个交叉的线叫 epipolar line， 就这一点的 epipolar line。所以任何一点在 3D 在两张影像都有自己的 epipolar line， 那就可以去找它的对应点，这样子。好，那再来是讲说 stereo，因为 stereo have a three kind of setup。stereo 就两只摄影机基本上有3种设定方式。第一种就是有角度，两只摄影机之间 ，the first one。If two camera is not parallel， 就有角度 angle， 那这样的话就是第一种。So you will find epipolar here, epipolar here. The second position， 第二种方式是假设这本来就有角度嘛，那我假设我要看前面，那一只摄影机就变成平行，那一只有角度，要看侧面。So this second kind of setup of camera， 第一种是我要看前面，我two camera 是这样，两只都就交叉，然后看前面，但是它有个角度，这第一种方式，因为你要聚焦嘛，我要看一个物体，那我两只摄影机就是有个角度在看物体，这样子看。这 the first one setup。The second is camera here. The camera will parallel to the object.But the other camera is here because I want to see the side view。我希望有点角度看它这样子。第二种方式，那这种方式的时候会出现个问题 ，Your epipolar here will be at infinity， 因为你要这个投影过来会 infinity， 你 C2 project 到 C1， 你会到无穷远的地方，所以这条线会到无穷远的地方。就你这一点，这条线对应到这条线，这个会你的 epipolar 会到无穷远的地方。那 epipolar 有一个特色，就是说会聚焦在一点，这些线连起来以后，所有的线连起来都会经过这个 epipolar。这边所有的线连起来都会经过这个 epipolar。那所以所有的线都会记得 3D any points project on your image. If you connect to the epipolar, so any image plane, any point in the image plane you connect, so all the epipolar line will pass through the epipolar. All the epipolar line will intercept epipolar， 因为你都跟 epipolar 连在一起。那这里会出现一个问题，我再把这个讲一下。So any point, but because this is parallel, right? And this is an angle. So any parallel point, epipolar line, they will intercept on infinity. 这也是任何的平行的 epipolar line， 它在无穷远的地方，像类似那个 rail， 那个 train 的 rail， 火车平行线会交叉在无穷远，所以它 epipolar 会在无穷远交接。那第三种状况是，我们喜欢是这种状况，就两个摄影机是平行的，那这样 in this situation your epipolar will intercept in infinity, so in the left hand side have one epipolar at the infinity. Your right hand side, your epipole in the infinity position. Why we need this one? This one actually is this situation 平行的，这样的话我们比较 easy to find corresponding point。不然你有斜度的话不容易找。So we prefer this one. So even though we have 3 cover situation for the setup, the first one, the second one, the third one, but we prefer use this one. So next year, sorry, next week I will talk about how can we find the epipolar line. So after epipolar, because we try to find epipolar line, we can use we try to find epipolar line. We will use essential matrix. We will talk about essential matrix. We will talk about fundamental matrix. So essential matrix and the fundamental matrix is help you to find the epipolar line. So after you find epipolar line, you can find corresponding point, and you can reduce the 2D search to 1D search along the epipolar line. So I need to teach you the essential matrix and the fundamental matrix. So after this one, we have the corresponding line we call epipolar line, and then we just try to find corresponding point, and that's it for the stereo. 所以 stereo 最重要就是要找出它的相对应的线，叫 epipolar line。那有线，最后就找到你的 corresponding point， 那就结束了。所以最主要后面都是在讲这些问题。OK， 那最后是 you have left and right, so you can find this is called disperity map。这个就是你的深度图。你只要找到 corresponding point， 你就可以产生这个深度图。那越靠近你，就是越那个 disperity 越大嘛，越远离 disperity 就越小，就可以做这种 depth segmentation。那 so far the depth segmentation, for a small image you can use deep learning to solve it, and the result is pretty good。那我们这就是可以找到，那后面就解决这个问题了。所以 stereo 就是主要就是要 stereo。The purpose is try to find corresponding point. Corresponding point, the distance between the corresponding point we call disparity. That's our purpose. OK， 那我今天这个讲到这里，那 next hour we will talk about the deep learning。先到这边，谢谢。